In this topic, indices and standard form, we are going to look at what we call an index. If we consider a number like, let's say a letter, A times A times A, this gives us A raised to power 3. This 3 is called an index, and this is what we call the base. Now, index, by the name, index can also mean a power. So, how do you pronounce this thing? You say A cube, or you say A raised to power 3. So, we say that this 3 here is the power of A, and it's also called the index. Plural of index is what we call indices. The plural form of index, or plural form of index is indices. So,
Uncle, please, I can't see what you're right.
Indices refers to the plural of index. So we're going to look into the laws of indices. Remember, this indices we are studying is for the junior category, so we are not going to state all the laws. When you get to your senior secondary class, you get other laws of indices. Now, the first law of indices is what we call the multiplication law. The multiplication law. In this multiplication law, we have this. It states that what? When two or more terms multiply themselves, if they have same base, we add their powers. When two or more terms multiply themselves, if they have same base, you you add their powers. What do we mean by that? Look at, if you have A raised to power 3 times A raised to power 4, what we have will be A raised to power 3 plus 4 to give us A raised to power 7. Then in general, if you say S raised to power m times S raised to power n, it means S raised to power n plus n. This is the general format for it. In this case, you say y times y times y. You say it is y raised to power 3. What do you notice here? The power of this y is 1. When you add 1 plus 1, you have 3. Now, we are able to add this thing because they have the same base. If this is b and this is what? Y and this is x. You are not going to have this power 3. But once the bases are the same, you have the power to add. Okay. The second example here, if you are giving anything like s raised to power 3 times s raised to power 2, This thing, when you want to expand it, can give us something like s times s for this one, times x times x. This 2 is for this one, this for this. What do we now notice? 1, 2, 3, 4, 5. That is.
Uncle, I've not finished copying that laws of indices.
Now, okay, don't worry. Face the ball to that side. You notice that this is same thing as saying s to the power 3 plus 2 is equivalent to say what? 3 plus 2 is same thing as 5. So you have noticed here that once you are giving numbers or big letters, so far as they have
Uncle, I can't see the laws of indices.
No problem, I will get to that. Now, once they have the same base and they are multiplying themselves, the only thing you do is to add the powers. Now, in this one also, if you have something like 6 to the power 4 times 6 raised to the power 3, it's same thing as saying 6 raised to the power 4 plus 3 to give us 6 raised to the power 7. So this is the first law, which we call the multiplication law. If you have something like 3c raised to the power 5 times 2c raised to the power 6, you notice that what? We have 3 here and you have 2 here. So you can easily open it up to give us 3 times 0 to the power 5 times 2 times 0 to the power 6. You can see that 3 times 2 times C5 raised to the power 5 times C raised to the power 6. If you want to open up, you can open up as we did earlier. But in this case, they are going to multiply themselves. 3 times 2 is equal to 6. And you apply the laws of indices in this case because they have the same base. You add their powers since they are multiplying. To give us 6 c raised to the power 11. This is the answer to this question. That example, sorry. Now, you see this example, simplify the expressions. A, 10 raised to the power 2 times 10 raised to the power 5. B, 10 raised to the power 5 times 10. C, 5s cubed times 4s squared. D, 4y raised to the power 6 times 7y raised to the power 5. E, 3a cubed times 8a raised to the power 4. And F, a cubed times a raised to the power 7. This is B, the C aspect times 4s raised to the power 2. So you can easily expand it to be 5 times s times s times s times 4 times s times s. You have 5 times 4 is 20. S is how many here? 1, 2, 3, 4, 5. Which is what you have when you add the powers up. So D, we are going to do D directly. This will be 4y raised to the power 6 times 7y raised to the power 5. 4 times 7 is 28. Y raised to the power 6 plus 5 to give us 28. Y raised to the power 11. So these are the answers to the question. Now this one is 24 a raised to the power 7, and this is a raised to the power 10. That's the answers to the question. In this division law, the first law, we expect the law in terms of sentences or using sentences. In this case, we are going to just need use your mathematical term to say what you want to say. Now, in this case, now, if you have anything like this, or we make it this form, S raised to power A divided by S raised to power B. As we have the same base, remember, what you do is to subtract the power. What this thing is that S raised to power A divided by S raised to power B is same thing as S raised to power A minus B. You subtract their powers. So let us look at an example. If you say S raised to power 6 divided by S raised to power 4, you know this is same thing as saying S raised to power 6 over S raised to power 4. Now, you can easily multiply this. You can easily multiply that to give us, this is 6, this is the division sign here, this slash number. This times this times this times this times this. Okay, making it 6 all over this times this times this times 6. Now this is what 1, 4, 5, 6, x, and that's s raised to power 6, and 1, 2, 3, 4, s raised to power 4. So if you want to cancel them out, if you want to cancel them out, look at what you're going to have. This cancels out this cancels out this cancels out this cancels out this. So you're going to have what? 2 s raised to power 2. Remember, this is what s times s to give us s raised to power 2. So what do you notice here? That s raised to power 6 divided by s raised to power 4 is same thing as s raised to power 6 minus 4 to give us s raised to power 2. You see, they are the same. So what we have here as our result, in this case, what we have here as our result is same thing as what we have here when we expanded the term. If you have something like this now, check a raised to power 7 divided by 3a raised to power 2. What do we have here? Notice that this is 12 a raised to power 7 over 3 a raised to power 2. So this is 12 times a times a times a times a times a times a all over 3 times a times a. Now, we go with a 1.
Uncle is 10 o'clock on the door.
Is 4 times a times a times a
No space.
times a times equals 4. Now, using the other method can also give us
Okay, 10 o'clock.
divided by divide itself is 1. 3 divided itself is 4, and 12 is what? 4. So we now have 4 this is subtract this power. So this is how we apply the second law of indices, which is the division law. Now, assignment to say simplify the following use e raised to power 4 times 5 e raised to power 10, b 4s times 5s raised to power 5, c 10a raised to power 8 divided by 5a raised to the power 6, and D, 10 raised to the power 9 divided by 10 raised to the power 7. Using laws of indices, simplify the above. We will be willing
Uncle,
to
the thing
receive
is
your
hanging.
answers, and thank you.
Special point. 1, 2, 3.